Good afternoon, sir. I'm Pedro Tamura from BSMT1 Dubay. What is metacentric height and its uses in the measurement of stability? A ship's initial stability is measured by its metacentric height, the distance between the ship's center of gravity and its metacenter. Greater GM means greater stability and better resistance to tilting. Uses in stability measurement. During design, naval architects use GM calculations to determine the appropriate dimension and weight distribution of a ship to achieve the desired level of stability. During operation, the ship's GM is constantly monitored throughout its voyage. Changes in cargo, fuel consumption, and ballast effect at the location of the center of gravity, thus influencing GM. If GM becomes too low, corrective actions is necessary, like shifting cargoes and adding ballast. The damage control. In the event of damage, such as flooding of compartment, the GM can be calculated to assess the remaining stability and guide the damage control efforts. Regulations. International Maritime Organization like IMO set minimum GM requirements to ensure different types of ship adequate safety. What is initial static stability? Initial static stability refers to a ship's inherent ability to resist overturning when subjected on an external heeling moment, such as from wind or waves, before it starts to dynamically respond. It essentially the ship's resistance to initial tilt, focusing on the forces and moments of play at the very beginning of the healing process. This initial resistance primarily determined by the metacentric height, GM. A higher GM indicates greater initial static stability. It's important to note that this is only initial static stability. Dynamic stability, how the ships behave as it heals further. It's also crucial for overall seaworthiness. So, how to determine type of stress based on the given forward, aft, and midship draft. To figure out what kind of stress a ship keels or deck is under, we need to know if the ship is sagging or hugging. We find the average draft fore and aft draft added together and divided by 2, and compare it to the draft the middle of the ship. This comparison tells us the type of stress. Note, if the draft at the midship is greater than the mean draft, the ship experiencing sagging. If the midship draft is less than the mean draft, the ship is undergoing hugging. In sagging condition, the keel is subjected to tensile stress, while the deck experiences compressive stress. Conversely, in a hugging condition, the keel is under compressive stress and the deck experiences tensile stress. And so, as for number 37, with the mean draft of 10.50 and the midship of 10.80, knowing the midship draft is higher than the mean draft, so this is sagging moment. And sagging moment, the keel of the ship experiences tensile stress, so the answer is tensile stress. And number 38, since the mean draft is 10.850 and the mean draft at the midship is 10.80, and the midship draft is higher than the mean. This suggests that the vessel is sagging condition, where the middle of the ship is lower than the ends. As a result, the ship is undergoing a sagging moment, which causes the deck to experience compressive stress. Thus, the correct answer is compressive stress. And so, as for number 39, the mean draft is 10.50, while the midship draft is 10.40. Since the midship draft is lower than the mean draft, this indicates a hugging condition, where the center of the ship is higher than the ends. The result is hugging moment, causing the deck to subject tensile stress. Therefore, the correct answer is tensile stress. For number 40, the mean draft is 10.50, while the midship draft is 10.40. Since the midship draft is less than the mean draft, this indicates hugging moment. In hugging condition, the keel of the ship experiences compressive stress. Therefore, the correct answer is compressive stress as for number 40. And that is all, sir. Thank you.